last class I explained the concept, which is it's a measurement of responsiveness of quantity demanded to a price change, right? And then we talked about how to calculate, right, the price elasticity of demand, right? And based on the concept, we tried a couple of examples, right? But as we found out, when we use this the formula, calculation formula, based on the concept, we had a problem. The problem was because we were calculating arc elasticity rather than point elasticity, right? In other words, in this course, we are calculating elasticity between point A and point B, right? Or on a segment, on a demand curve, right? Rather than at one single point, right, on a demand curve, right? So the problem was whether we go down, or in other words, whether the price decreased or increased. We got two completely different answers, right? Because we were using, first time we were using A as the starting point. The other way around, we use B as the starting point, right? So at the end of last class, I suggested instead of using those either A or B as the starting point, we're going to use a midpoint between A and B as the starting point, right? Then, whether we lower the price or raise the price, we're going to get exactly the same answer. Okay? That's the idea. Okay? So here, the formula would go this way, right? Q2 minus Q1 instead of Q1, right? We're going to use the average between Q1 and Q2, right? This is the average of two Q values, right? And here, instead of P1, we're going to use the average of two P values, right? And then we're going to end up with this formula, right? So, well, unfortunately, you'll have to memorize this formula, right? For the exam, right? Because you're not going to be allowed to use cheat sheet, right? But, well, if you don't want to memorize, you can think about it and derive this formula yourself, right? It's not going to take much time anyway, right? And at least, I mean, that much I think you can memorize, right? Again, in this course, there aren't many things to memorize, right? But, you know, I mean, you don't have to memorize if you don't like to. If you just understand the concept, you can easily come up with this formula yourself, right? But I guess during the exam, if you want to save time, right? Maybe. Yeah. Anyway, so this one, if you think about it, is actually 1 divided by slope, or inverse of slope, times this term, right? So in this formula, the first term here, this is actually inverse of the slope, because if you have a demand curve like this, let's say this is P1, Q1, wait. Yeah, whatever. Yeah? Let's say P1, P2, Q, whatever, 1, Q2. Okay. The slope is this distance divided by this distance. Okay? Right. So P1, Q2 minus Q1 is this distance, right? And P2 minus P1, right, is this distance. Okay? So if you divide those two, that's the slope is this distance divided by this distance, right? So what we have here, right, this is actually the inverse of the slope. Okay? So if you have a straight line demand curve like this, what that means is the slope is the same at all points on this demand curve, right? Because if it's a straight line, whether you measure the slope at here or here or here or here, slope is constant. Okay? So regardless of the location, right? If you measure, when you calculate the elasticity, the first term here, first part is the same. Only the second part will be different. And second part will be different at different point on a straight line demand curve. Okay? In other words, on a straight line demand curve, elasticities will be all different at different points on the demand curve. Okay? So what we can think of here is, let's think about this situation. Okay? Okay. We have a flatter demand curve and steeper demand curve. Okay? And which one has higher slope? Larger slope. I mean, in terms of absolute value of slope, right? Which one has larger value? D2, the steeper one, right? You know that, right? If, let's say, if we have this two lines, let's say, right? If this is 5, and if this is 1, and let's say this is 5. I just polished this shoes. Okay. Alright, so if it's a steeper one, the slope is what? Negative 5 over 1, right? Which is negative 5. So absolute value is 5, right? If it's a flatter one, this is what? 5 over 5, right? Or negative 1. You know that, right? Okay. So when you think about this formula, right? Think about this formula here. Right? If you measure the elasticity of two demand curves at this point A, think about it. Right? Right now you're trying to measure the elasticity for these two different demands, right? But you want to measure the elasticity at this one single point. Okay? Which one will be more elastic? In other words, which one will have higher elasticity? When we say higher elasticity, we're talking about absolute value, right? Because price elasticity of demand is always a negative number, right? So forget about the sign, just think about the absolute value of the elasticity. Which one will have higher value for elasticity?
Flatter one.
Flatter one. You agree? Well, for the flatter one, the slope is smaller. Is that right? Okay. So if the slope is smaller, this first term will be larger. Yeah? The smaller the slope, the first term, the larger the first term, right? What about the second term? Second term will be the same between D1 and D2, right? Because we are measuring the elasticity at this point A, right? At one single point, right? So here, one thing we have to learn here. So if you are measuring elasticity at one, the common or crossing point, right? Then the flatter demand curve has higher elasticity at that moment, at that point, right? And the elasticity for the steeper demand curve will be lower, right? If you rephrase it, right, we can say that at this single point, at this value of price and quantity, right, demand for one, whatever the product is, has higher elasticity, right? And demand for two, right, this product has lower elasticity, right? So some of you apparently learned the economics in high school, right? And somebody this morning showed me this something like this. Okay. He said, okay. According to his memory, right? Elasticity for this is vertical, horizontal, right? Elasticity for this is 0, and this is infinity, and this is 1. So this is between 0 and 1, and this is between 1 and infinity, right? Have you learned like this? Okay. Well, that is true at only one point, at this point. Yeah? If you're measuring elasticity at this point. Okay? But at any other location on the demand curve, like here or whatever, that is not true. Because if you have a straight line demand curve, right, elasticities are all different where you are, depending on where you are, right? You will have different elasticities. Okay? Make sure you understand that clearly. Right? So, first thing, yeah, so let's finish this one. Okay? So, although the slope and price elasticity demand are related, how related? How are they related? Look at this formula. Okay? Elasticity is 1 divided by slope times this, right? So slope is related to the elasticity, right? But they are not exactly the same thing, because elasticity depends on this value. And this value is determined by location on a demand curve, right? If you are on the upper part of the demand curve, you're going to have high P value and low Q value, right? If you are on the lower part of demand curve, you're going to have low P value and high Q value. Okay? Make sure you understand that. Okay? Yeah?
And what about the elasticity at one point?
At one point?
Yes.
You mean this crossing point? A?
Anywhere.
Anywhere?
Anywhere.
Like here?
Yeah.
Okay, yeah. So if you ask, right, between okay. Suppose we have two demand curves like like this, right? D1 and D2, right? If you ask between D1 and D2, which one has higher elasticity? What do you think the answer is? D2? Because I just gave you the answer, right? But I told you if you are measuring the elasticity at this point A, then you can say flatter demand curve has higher elasticity than steeper demand curve, right? This one, the correct answer is you cannot say which one has higher elasticity, because depends on where you are right now, right? So if you measure the elasticity at this point for D1, and if you measure the elasticity for D2 at this point, or maybe the other way around. Hold on. Yeah, I mean, the other way around. Suppose you measure elasticity at this one, P1 and Q1, right? And if you measure the elasticity at this point, P2 and Q2, right? Even though typically the higher slope will make lower elasticity, right? Because we have this term here. So if you can say this second term is fixed or same, right? Then it depends on the slope, right? But if you cannot say this second term is exactly the same, in other words, if you are measuring the elasticity at two different points, right? Then there's no way you can say the flatter demand curve has higher elasticity rather than steeper elasticity. Because, let me say one more thing here. Okay? If you have a straight linear demand curve like this, let's say this is a straight line, okay? Then on top of this demand curve, if you calculate elasticity at this point, it's going to be infinity. And at this point, at the bottom of the demand curve, elasticity will be 0. And if you can say this is a midpoint, let's say, okay? If you calculate the elasticity at the midpoint on a straight linear demand curve, elasticity will be exactly 1. I'll prove it in a few minutes. So that means between here and here in this region, elasticity will be greater than 1. In this segment, elasticity will be less than 1. Okay? Well, let me prove it. All this thing. Okay, okay, so using this formula here. So elasticity is 1 over slope times whatever, P1 plus P2, Q1 plus P2. Okay. So okay, let's say which one would be easier? Yeah, let's think about it. Let's say suppose we are measuring elasticity at this top end of the demand. Okay? So if we calculate the point elasticity, it's very easy. But let's say we calculate arc elasticity. Okay? So we're talking about very minute movement from. Yeah. So here's the initial price P1. Okay? And suppose we lower the price slightly, very small amount, right? Very tiny amount. Okay? Right? Okay? And that means if the price was P1, quantity would be 0, right? If price comes down to very slight amount to P2, then quantity will be very 0.000000001, right? Q1 will be 0, Q2 will be very small amount, right? So think about it. Then it's going to be the slope is P1 divided by Q, whatever, Q2. No, which? What should I say here? Okay, Q1, let's say. Because, okay, let me say, what should I do? this intercept is, let's say, P whatever star, and this intercept is Q star. Okay? So let's say we are calculating elasticity at very end, right? And that means P1 value was P star, okay? And P2 value was P star minus very small amount, right? Whatever. You understand what I'm saying? Okay. So here the slope is P star divided by Q star. Actually, yeah, that will be actually a negative amount, but anyway. So yeah, that's going to be P star 1 over P star. Okay. And times what? P1 plus P2. Right? And that's going to be P1 was exactly P star. Right? So P star plus P star minus 0.01, okay? Divided by, okay? Here, Q1 plus Q2, right? So that's 0 plus 0, 0, 1. Understand what I'm doing here? Actually, you understand, right? I'm just trying to illustrate the calculation of this arc elasticity, right?
Calculate at that point P1.
Yeah, we're trying to calculate elasticity at this end, this intercept, right? And since we want to use the formula for arc elasticity, right? So we assume that the price changed very slightly, right? Price is lowered by 0.001, right? So quantity increased by 0.0001, whatever, right? So then we arrive to this formula. So that is Q star over P star times what? Almost 2 times P star, right? 2 times P star minus 0.01, right? Over what? Almost 0, right? Okay? So the point is, well, we don't know what the slope is, yeah? Whatever the slope may be, right? And we don't know what this number is. Could be any number, but this one is almost 0. Well, if it's exactly 0, then what? It's undefined. You cannot divide any number with 0, right? There is no answer, right? But if it's a very, 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 very extremely small number, it's going to be infinity, right? Does that make sense? Okay. So towards this end of the demand curve, we find out elasticity is infinity. Okay? Well, here at this bottom end, you can do the same thing, right? Again, the elasticity will be, right? It's going to be Q star over P star times here. We're talking about a very infinitely small change at this point, right? So price will be something very small plus 0, right? Because P1 will be here and P2 will be here, right? We're talking about from this point to this point, we are either raising or lowering price by small amount, extremely small amount, right? So according to this formula, we're going to have Q star over P star times 0 plus 0, 0, 0, 1 for this value, right? For this value, Q1 and Q2 is going to be what? Q star plus, right? Or minus, sorry. Q star minus 0.0001. Okay? Oh. Q star plus Q star plus Q star minus 0.0000. Because we're talking about from moving from this point to slightly higher price. Right? Okay? So, well, we don't know what this value is. We don't know what this value is, but this is almost 0. Right? So, we can say the elasticity is almost 0, as you can say. Right? Well, if you calculate point elasticity, you will get exactly 0, right? But since we are talking about the arc elasticity, very minute change here, right? So it's going to be very, 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 very close to 0, right? Okay? What about here at the midpoint? Well, if it's the midpoint, this value is 1/2 P star, right? And this value will be 1/2 Q star. Okay? So, if you calculate the elasticity at that point, it's going to be, the slope is still P star divided by Q star. So 1 divided by slope is Q star divided by P star, right? Times, well, that's 1/2 P star plus 1/2 P star, right? Well, of course, yeah. If you're calculating arc elasticity, maybe we are changing from this to slightly below that value, right? So P1 is 1/2 P star, P2 is 1/2 P star minus something, right? So, and then the bottom here, we're talking about slight increase in this value, 1/2 Q star, right? So that's 1/2 Q star plus 1/2 Q star plus 0.0001. Okay? We are assuming we are lowering the price by slight amount, right? So the quantity will increase by a very small amount. Okay? So, let's ignore this value, right? Then it's going to be what? Q star over P star times 1/2 P star plus 1/2 P star will be P star, right? Divided by Q star, right? So that's exactly 1. Right? Alright, so we have proved that as long as you have a straight linear demand curve, and it doesn't matter whether it's a steep or flat or whatever, right? The slope doesn't matter, right? As long as you have a straight linear demand curve, right? At the top of the demand curve, elasticity is infinity. At the bottom, it is 0. Right at the midpoint, it is 1, right? And the upper part, it is greater than 1. Lower part, it is less than 1, right? So if you calculate the elasticity here or here, you're going to get two different numbers, right? On a straight line demand curve, elasticity are all different. There are no 2 points that will have same elasticity. Okay? So this is not entirely correct. Right? This is true only at this one point. Okay? Because at any point on this single demand curve, elasticity are all different. Okay? Make sure you understand the concept exactly. Alright, so we talked about all this here. Well, what about the vertical and the horizontal demand curve? Right? If it's vertical, what that means is no matter what the price change is, right? No matter what the price change may be, your quantity doesn't change at all, right? In other words, quantity demand is completely unresponsive to the price change, right? Quantity doesn't change whatever you do with the price, right? So we call it perfectly inelastic, right? Perfectly inelastic. Is there such thing which has perfectly inelastic demand? Can you imagine?
Elastic demand.
Inelastic demand. Is there anything you can imagine with perfectly inelastic demand? In other words, whatever you charge, even if you charge $1 million, raise the price from $1 to $1 million, right? People still buy the same amount of this product or service. I don't think you can find any inelastic. What did you say? Oil? You mean crude oil? That produces gasoline or something? No. The demand may be very steep, right? Because oil is a necessity, right? But I don't think it is perfectly inelastic. If you raise the price to, right now, let's say oil price is $100 per barrel, right? If you raise the price to $150 per barrel, then the quantity demanded will go down significantly, right? The only hypothetical example I can come up with is this. Let's say somebody come up with the cancer treating drug. Let's say, right? And with this drug, yes, you can cure the cancer. You can save life, right? And because the production process is so complicated, they were able to produce only, say, 3 units. So in other words, in the entire world, right, you have only 3 units available. In other words, you can save only 3 people, 3 lives, right? And let's say current price for this drug is $10 million per unit, right? And then they raise the price to $100 million per unit, from $10 million to $100 million, right? So, well, when it was charging $10 million per unit, well, of course, they were all sold, right? Because only 3 lives can be saved, right? So I'm sure there are 3 people in this world, right? At least 3 people in this world who can pay $10 million to save his or her life, right? Well, what if they raise the price to $100 million? I'm pretty sure there are 3 people in this entire world, right, who can come up with $100 million, right, to save his or her life, right? So even though the price became 10 times, the quantity demanded doesn't change at all, right? That's probably the situation for vertical demand curve, right? So regardless of the price, quantity demanded doesn't change, right? But that's a very hypothetical, imaginary situation, right? I don't think in this real world we can come up with an example of perfectly inelastic demand, right? Easily, right? Realistic example, right? How about horizontal? Horizontal demand means if you change the price only slightly, very slightly, raise or lower the price, right? Then suddenly the demand disappears, right? So we have, okay, let's say right now, let's say this is horizontal demand, right? So apparently the price is P star right now, right? And if the price goes up even slightly, right, then absolutely no demand there is. The quantity demanded becomes zero. Right? Right? Can you imagine such thing? Well, when we learn perfect competition, right? The first market structure we usually learn is perfect competition, right? There are a few conditions to have perfect competition, and perfect competition is an imaginary market structure, right? There is no example of perfect competition, right? Well, even though every country, every economy tries to promote the competition, right? But perfect competition requires very stringent conditions, right? Like infinitely many producers, right? In order to have perfect competition, you have to have infinitely many producers who produce identical product. So there are so many producers, right? But they are producing identical product or homogeneous product, which means there is absolutely no difference between A's product and B's product, right? There is no such thing, right? So a typical example that we use is a wheat. There are so many wheat farmers, right, in the world, and they all produce wheat, right? And say wheat is wheat, right? And ordinary people cannot tell the difference between Farmer Jones's wheat and Farmer Smith's wheat, right? But that's still not a perfect condition, right? I mean, there are not infinitely many farmers, right? And then there are differences between wheat, right? The wheat produced in Illinois is different from wheat produced in Alabama or whatever, right? So, and there are different species of the wheat, right? Well, if imagine the conditions are satisfied, right? So suppose this is the demand for wheat, right? There are so many producers who supply wheat to the market, right? And they are all charging right now, let's say $5 per bushel. Okay? And then one of these farmers, let's say you are one of these farmers, right? And you try to charge $5.01, right? $5.01 per bushel. What's going to happen to the demand for your wheat? Suppose you were selling, say 1,000 bushels per month, right? At $5, right? And all other farmers charge $5, and every farmer sells exactly identical wheat, right? And suddenly you try to charge $5.01 for your wheat, right? What's going to happen to quantity demanded for your product? Yeah, it will become immediately, it will go zero, Why would anybody buy your wheat, right? Paying 1 cent more, right? If there are so many farmers, right? Right next to you, there's another farmer, right? And on this side you have 1,000 farmers next to you, right? And they are all producing the same thing, right? Right? That's the idea of horizontal demand curve or perfectly elastic demand curve, right? So even for a slight change in price, right, the change in quantity demanded will be what? 0? Infinity. Right? Elasticity will be infinity, right? Even for a slight change in price, change in quantity demanded will be infinite, infinitely large amount. Okay? All right, so that's the idea. So I'm not sure there's a, yeah. This is just an example of a inelastic demand, right? So I guess somewhere in the chapter they asked the question, right? Well, the gasoline demand is very inelastic. Yeah. So what's going to happen to the quantity demanded for gasoline if supply shifts or shifts to the left? In other words, if the supply decreases, what's going to happen to the quantity demanded for gasoline? Well, yeah, even if the gasoline is a necessity, right, it still is not a perfectly inelastic product, right? So it's not really a vertical line, right? It's more like this way, right? It's rather steep, right? Which means for certain amount of price change, right, the change in quantity demanded will be relatively small, right? Or consumers are relatively unresponsive, right? Unresponsive to the price change, right? Because even at a little higher gas price, you still have to work. You still have to go to work, right? You have to drive your car, right? You have to go to school. You have to go to what? Whatever. Hospital, travel, you know. So, yeah, that's the idea, right? So steep or relatively inelastic demand, right? Gasoline is not a perfectly inelastic product, yeah? All right, so let's see. What are the factors that determine this elasticity? What makes elasticities higher or lower, right? Well, the availability of close substitutes. So here we're using an example of gasoline and Nike shoes, Reebok shoes, or Adidas shoes, right? Between gasoline and these athletic shoes, which one will have higher elasticity? Shoes, right? Because they have close substitutes, right? So if the price of Reebok goes up, right, then, well, people don't have to buy Reeboks, right? You can buy Nike or Adidas, whatever, right? So the quantity demanded for Reebok shoes will go down significantly, right? But for gasoline, right, there isn't much substitute, right? Diesel, maybe? But, you know, a lot of people still already have cars that use gasoline, right? They cannot use diesel on gasoline car, right? So, you know, demand for gasoline will be rather inelastic. Okay? The same idea of this, I will just talk about the wheat farmer, right? If you assume that there are so many farmers who produce the same wheat, right? Then there will be, what, for Farmer Jones's wheat, the elasticity will be infinity, right? Because we assume that there are infinitely many other farmers. Okay? But what about just wheat? We're talking about, this is actually individual demand. Oh, okay, sorry, I forgot to mention it. I'm sorry. When you learn a perfect competition, right? This is the starting point. The starting point, the assumption is this is the demand curve for individual producer. So say Mr. Jones. Yeah? This is for Farmer Jones. Okay? So because Farmer Jones faces so many competition, there are so many alternatives or substitutes for Farmer Jones's wheat, right? Demand for Farmer Jones's wheat is horizontal or infinitely elastic, right? But what about wheat itself? What's the demand for wheat or market demand for wheat, right? Market demand is different, right? This is the demand for wheat. Okay? So demand for wheat is downward sloping, and there is a supply for wheat, right? So the price is determined at the market, right? And once the price is determined at the market, every producer in this market, in this industry, must accept that price, because otherwise, if you try to charge a little bit higher than the market price, you won't be able to sell anything, right? All your demand disappears. What about charging a little bit less? If you charge a little bit less than the market price, what's going to happen? What's going to happen to your demand for your product? Nothing. Because the assumption is, under the perfect competition, the assumption is as long as you accept the market price, right, you can sell as many as you like. Whatever you produce, well, actually, there is a this quantity will be determined by eventually this situation. This is marginal cost and ATC, right? So average total cost and marginal cost. At that point, your the quantity, profit maximizing quantity is determined, right? So it depends on individual farmers' conditions. Some people have lower cost, some people have higher cost. You know, if you have better equipment and better skill, your cost will be lower, right? If you have more deteriorating environment or dilapidated equipment, right, then your cost will be high, right? So if you're, depending on your cost, your profit maximizing quantity will be determined, right? And the story is, as long as you accept the market, or actually this profit maximizing quantity is determined at the price, the market price, right? So you don't have to worry about, I mean, there is absolutely no reason to lower the price below the market price, because at that market price you can sell all you can produce, all your profit maximizing quantity. Okay? Why would you charge a lower price? Why would you charge $4 if you can charge $5 and still sell everything you have? Right? That's the idea of this horizontal demand curve. Have a question? No? Okay? Yeah. Okay, so that's the idea of perfectly horizontal. Oh yeah, okay, so we already did. Okay, so the cross substitutes, we'll talk about that. The length of time over which elasticity is measured, right? So in order to measure elasticity, what kind of information do you need, or what kind of data you need, right? Well, you need to collect the price and the quantity demanded, right? Information, right? And so these observations can be either cross-sectional data or time series data. You will learn about the difference of these two different types of data in statistics, right? Economic statistics. Probably you'll have to take it next semester, right? Okay. Cross-section data means you can collect this price information across different person or different company or different region, right? So let's say this is gasoline price in Phoenix, Arizona, Charlotte, North Carolina, or Chicago, Illinois. You collect the average gas price in different locations, right? And the quantity sold at that price, right? And then using this information, you can calculate the price elasticity, right? Or you can collect this information over different time, right? Say December 1980, the January 81, February 81, you know, so you say you have monthly data on price and quantity, right? So you can use time series data to calculate the elasticity, right? But let's say, anyway, so using this data over a short period of time, suppose you collect this, let's say you're using cross-section data, right? Different cities, right? But you have collect this data over 1 week period. Okay? So the maximum time difference here is 1 week. Okay? Versus, suppose you collect this data over a 2-year period. Okay? There will be difference in the elasticity, right? In which case you will find larger elasticity or higher elasticity. 1 week versus 2 years. Sorry, 1 week versus 2 years. Remember, we're trying to measure the elasticity, which is a percentage change in quantity demanded over percentage change in price, right? So when the price changes, by how much the quantity demanded changes, right? So if you collect that information over 1 week versus 2 years, right? In which case you're going to have larger response or stronger response for price change. Why? Think about yourself, right? Let's say gasoline price went up from $3 to $5, right? Can you change your schedule, let's say? So can you say, hey, I'm not going to go to school this week, tomorrow, or this Friday, because gasoline is so expensive, right? Or if you have a business meeting, you have a business trip already scheduled, right? Can you call and, hey, we have to cancel the meeting because gasoline price went up, I can't drive there, right? Probably not, right? People still have to go to work and have to work, and you have to still have to go to market, right? Right? Well, maybe instead of going shopping, the grocery shopping every day, right? Maybe you decide to go maybe every 3 days or every 5 days, right? Maybe people can do that, right? But you cannot adjust the behavior so quickly, right? But if you're given 2 years of time period, right? Then people will do everything. Maybe they'll move closer to work, right? The next time you rent your apartment, right? You get the apartment somewhere close to your workplace so that you don't have to drive that much, right? And next year when you replace your car, right? Maybe you will buy more gas efficient car, or maybe you'll even buy hybrid or electric car, right? Whatever, right? So given sufficient time, people will adjust their behavior, right? So the responsiveness here will be larger, right? You can reduce the consumption of gasoline by a lot more, right? If you're given sufficient time, right? Okay, the next factor is whether the good is a luxury or necessity, right? We talked about the medical service versus vacation, right? So if it's a necessity like medical service or food or utility, right? You cannot really change the quantity consumed drastically just because price went up, right? But if it's a luxury, you don't have to have this thing, right? If its price is too high, right? Like vacation or whatever. What else is luxury in your life? Beer? Oh, it's a necessity. What about date? Cost of dating went up? What are you gonna do? Well, something like that, right? So, well, you can think of other examples, right? Well, share of good in a consumer's budget. Yeah. So typically in English, there's what we call big ticket item versus small ticket item. Right? Big ticket item means something like automobile or TV sets, right? Something rather expensive, right? So you don't buy these things very often, maybe once in a few years, right? And compared to that, think about something like toothpaste, right? It's very cheap, right? And I don't even remember how much I paid last time I purchased the toothpaste, right? So if they raise the price of toothpaste by 10%, would you cut on using toothpaste by a large amount? Yeah? Probably not. Right? I won't even recognize, I won't even notice the price change, right? If it's something like toothpaste, right? But if it's a big ticket item like an automobile, right? That's a significant expenditure, right? So if the price goes up by 10%, right? Then, well, the quantity demanded will be impacted significantly, right? That's the idea of a share in the budget. Yeah? So here are a few examples of real-world elasticity measurements, right? And some of things are quite interesting. Well, first of all, books. Books sold in bookstores, what they call bricks and mortar bookstores, actual bookstores. Right? That's very high, -4. Elasticity is 4. Yeah? So if they raise the book price by 10%, what are you going to see? In the first case, books sold in bookstores, right? If they raise the book price by 10%, according to this, what's going to happen? All right, quantity demanded for books will decrease by 40%, right? That's what they find out, right? But books sold in Amazon, that's interesting. Why? Why so much difference? E-book, okay? Because e-books are cheaper than real paper books. Yeah? Like a big ticket item and small ticket item factor.
More people's taste.
Hmm?
More people's taste.
More people what? Buy
Taste.
taste?
Yeah.
What do you mean? Taste?
Favorite.
Okay. Oh yeah. More people favor e-book rather than over the paper book. Is that what you're saying? Okay. So what about among these 4 factors? How does it explain? It's not a matter of substitute question, is it? Paper books. So does the paper book have close substitutes rather than e-book? No. Amazon. What about the luxury or necessity? E-book is necessity and paper book is luxury? I don't know. It's a little bit difficult to understand. What about DVDs? DVDs sold in Amazon. It's rather elastic. Post-Raisin Bran, it is explained in the next slide. It's a brand among the breakfast cereal, right? So although the Post-Raisin Bran has high elasticity, if you compare the larger category, all types of breakfast cereal, it's very low, right? Because it's a food item, which is necessity, right? So if you just say breakfast cereal, it's still necessity, right? But there are literally hundreds of different brands among this breakfast cereal, right? So the Post-Raisin brand has many close substitutes, right? So that's what makes the elasticity higher, right? Okay, what about Tide? Tide is a liquid detergent, a laundry detergent, right? Isn't a necessity? Laundry detergent, right? Why is it so high? Elasticity is 3.92. Any idea?
Because it's a liquid detergent, it's more like luxury to
Luxury. Laundry detergent is luxury? It's not really necessary?
people can buy a powder detergent.
Ah, okay, so you're talking about substitutes, right? Yeah, there are close substitutes, right? Okay, yeah, it's not just a liquid, but just whether it's a liquid or powder or whatever, right? There are so many different brands of laundry detergent, right? So, availability of close substitutes, I'm sure, right, is making the elasticity so high, right? I'm pretty sure if you just calculate the elasticity for laundry detergents, right, it's going to be pretty low, right, because it is a necessity, right? Okay, what about the food, water? Yeah, these are necessities, of course, right? So that's why it's so inelastic, right? There are interesting items like cocaine, cigarettes, and beer. They all have low elasticity, very inelastic demand. Necessity. Well, yes, that's true. Once you are addicted, right? Yeah, that's a necessity. Yeah. That's why, yes. Okay, now Catholic school attendance. That's really interesting thing. Right? I don't think there are many Catholic schools in Korea, right? But in the US there are many Catholic schools, which means they are private schools and expensive. Right? Catholic schools are expensive, and still it has very low elasticity. Right? So even if they raise the price of tuition, right? But the same people still go to Catholic school or still send their children to Catholic school because it is religion. Yeah? When we describe some people who are adamant, you need to do whatever. We use the expression religious, right? He is religiously, he does this thing religiously. That means once you become Catholic, you have to do such thing, I guess. Right? All right. Anyway, so the gas, gasoline, milk, sugar, of course they are necessities, right? And small ticket items, right? So both factors, right, make milk, sugar less elastic, inelastic, right? Okay, so the rest of the chapter is about the relationship between elasticity and total revenue, right? I already explained this last class, if you remember, right? I used the example of what total revenue is P times Q, right? What if price was $10 and quantity was 1,000 units, right? Okay. And if you lower the price by 10% to $9, right? And if the elasticity was greater than 1 or less than 1, right? Just imagine any number, right? Suppose the elasticity was 1 point whatever, something like that. No, it doesn't matter. 1.1, right? What that means is what? If you raise the price, if you lower the price by 10%, your quantity demanded will, let's make it 1.5 or 2, okay? Make it 2, it's fine, right? Then, what that means is if you lower the price by 10%, quantity demanded will increase by 20%, right? So it's going to be what? 1,200, okay? And that means the total revenue will increase, right? If the elasticity was 0.5, okay? Less than 1, right? Then, when you lower the price by 10%, quantity will still increase, but by only what? 0.5%. I'm sorry, the 5%. When the price goes down by 10%, quantity will increase only by 5%. Right? So instead of 1,200, it's going to be 1,050. Right? So if you multiply 9 by 1,050, it's going to be less than 1,000. So total revenue goes down. Right? So that's the relationship. You can just review the slides yourself. I already explained, right? Let me know if you have any questions. Yeah. All right. So why don't you? Next week we're going to cover chapter 8. Right? And chapter 8 is a little bit technical chapter. Make sure you read the chapter very carefully. All right. I'll see you next week.